Okay, this is the tile project. Question number 1, lay some limestone tile on the table, so right there, and measure its height, its thickness. So I put the ruler up like this. Perhaps I can show it to you like this. And what is the thickness of that? Number 2, the length and width of the limestone tile should be about the same. They are approximately, here's the length, let me lift that up for you. And the other way, the width. Number 3, find the volume of the limestone in cubic centimeters, multiply the length, width, and height. I'll let you do that on your own. Next is find the mass of the limestone. So I have here my triple beam balance. Put that up there, and we need to make this equal out. The white lines line up. So that's a pretty good balance. Whoops, where am I? That's a pretty good balance over there. So you can read your sliders there and back there. This slider is at 0. Okay, so that way you can find the mass. And so the density, number 5, finding the density of the limestone is using the equation mass divided by volume. Okay, next we have the regular rectangular marble tile, and that's going to be like that right there. So first step is to find the height or the thickness. Very similar to the limestone tile. The length, the longest dimension here. And the width. Multiply those together to get the volume. The mass of the marble, put it on the triple beam balance again. That's pretty good. There's one scale. Here's the other scale. And the last one. Kind of hard to see, that's a little bit blurry. But this is a 6 and that is a 7. So we got our mass. And now you can find the density for question number 11 by dividing the mass divided by volume. On the second page, we are looking at samples 1 through 5. Look at the 3 granite samples, 1, 2, and 3. Samples 1, 2, and 3, which is most likely to have cooled slowly. So here is sample number 1. Look at the crystal size there. Sample number 2. And sample number 3. The one that has the largest crystal size overall on the average is going to be the one that cools most slowly. So that's number 3. That's number 2. And that's number one, sorry. Okay, number 14. From the descriptions in the reading, which granite sample most likely cooled underground? So this kind of ties in with the previous question. Okay, number 15. Which two samples are metamorphic rocks? So we have sample 1, sample 2, sample 3, sample number 4 here. Kind of hard to see, but down here we have some wiggly lines. That's a sign of metamorphic rock. And number 5, we also have some wiggly lines here. And so those are signs of metamorphic rock. These are pieces of marble for marble flooring. Okay, next, samples A through J. Here's sample A. It says it's marble. It's made from heating and pressing limestone. What indicates that this is metamorphic rock? Look at the options available to you on the question sheet and look at this and see if you can figure it out. Next, sample B is pumice. Where's B? This is sample B. Notice all the holes in it. You can see them particularly over here. What kind of rock has holes in it? Letter C. This one right there. It's sandstone. Bits of sand are compacted and glued together. What kind of rock would that be? You can see the layers of the sand as they were blown across the desert somewhere. Sample D. Where's D? Ah. This is sample D. Has all sorts of pebbles, little tiny rocks that are cemented together in one big clump. This is a natural kind of cement. What kind of rock would that be? Sample E, fossilized dinosaur poop, otherwise known by a fancy word of coprolite. It just looks like a piece of gravel. I have no idea how they figured out that it was a piece of dinosaur poop. It's probably in a larger piece that broke into lots of little tiny ones. Anyway, since it's fossilized, are there any poop molecules left in it? Look at your readings, look at your notes to be able to answer that. So that is fossilized poop. What kind of rock is a fossil? Number 21. Number 22, sample F. There we have F. And you can see what kind of a surface it has. Those are holes. The black specks or the black appearance, black dots, are holes, pits in the surface. What do holes indicate in terms of a type of rock? Letter G, it's igneous. What aspect of this rock is making it obvious that it's an igneous rock? Letter H is this thing right here. That is the print of a fish. Letter I, fulgurite. Lightning hitting sand, melting it, and then cooling it into a rock. What kind of rock would that make it into? And then J. Where is my J? Here's J. This is granite countertop material, but it's a slab of granite rock. What's one of the reasons that this could be classified as igneous? Okay, that's the end of the tile project. Looking at all different kinds of construction tiles that you can buy at Menards, Home Depot, Lowe's, etc.